Hello. Today we're going to be talking about live audio systems as a whole, from the beginning kind of through to the end. This training is designed for first-time techs or those who know a thing or two, maybe have volunteered a little bit, but want to know more from the entire system point of view. This will be the first of several short training sessions that we'll be putting out, trying to keep things as simple as possible. There are lots of resources out on the web and videos when you start to get into more advanced techniques or properties, but not a whole lot for the first time person who doesn't know anything about a system and would just like to help out or just be part of a team. Of any audio system, live audio system, would be your original audio source where everything starts from. This can be voice, guitar, drums, anything like that, something that needs to be captured and then amplified. That then goes into the audio processor or mixer in most cases. That then gets sent into an amplifier, which takes this low voltage signal, amplifies it, and then brings it out to the speakers, which then turns it back into acoustical waveforms at a much higher level. As we explore the original audio source, like I said, this could be voice, usually captured via a microphone, people singing, people speaking, those types of things. Instruments, a couple of examples. We have acoustic instruments, violin, acoustic guitar, piano, captured via a microphone or an instrument pickup. These are electronic magnetic devices that work much like a microphone, but just do it in a different way. There's also electronic keyboards, CD players, sync tracks, these types of things already are electronic. We don't need to capture acoustic waves, turn them into electrical in order to work with them. In order to get any of these different sources into the mixer, we have to run them through the cables. So the most common is going to be your XLR or microphone cable. They have 3 pins, which carries a balanced signal and male and female ends. Now, there is a difference between balanced and unbalanced signal. We'll talk about that later on in another video. Then the next most uncommon are your 1/4 inch balanced signal cables. They work very much like the microphone cable, just different ends. Again, they have 3 wires going through them. The tip ring shield, just like the microphone cable, has 3 separate pins. It can be run balanced or unbalanced, and usually used for what's called line level connections. These have a greater signal voltage on them versus a microphone. Then we have more of the unbalanced signal cable. As you can see from the picture, it's missing the extra ring in there. These cannot be balanced at all, and they're usually used for like guitars, going from an electric guitar to amplifier. They can also be used with keyboards, older keyboards. You're seeing less and less of it because there's interference issues that can come up with them, but they are still very prevalent. The next, we have the speak-on connectors. These go from the amplifiers to the speakers. They are an insert and twist in order to lock them in, and then the tab on the top, you pull back and twist the other way in order to get it out. This carries high voltage or high wattage signals to the speakers. RCA connectors been around for a very long time. It is an unbalanced signal, usually connecting a CD player or a DVD player to the board. You'll see that like tape in, tape out, that type of stuff. These are very consumer grade based. Your home stereo systems will have that. And in the pro audio world, there's used just to interface with those types of systems. Eighth inch stereo is your common headphones type connector. Again, it's unbalanced, but the extra ring is one of the tip is one signal of the left or right pair. The ring is the other side, and then the shield would be the ground. So it is not interchangeable with a balanced quarter inch at all. A lot of times you'll see that. It'll actually lose out most of the audio when you do that. But these are your most common chords that are out there that you'll run across. And we bring all that into the mixing board. I have here just an example of a very simple, a little bit older style Mackie soundboard to just kind of go through with some of the regions and areas that you'll run across and things that are on them. Across the top, you're always going to have the gain or trim. It's called either or depending on brand. This is your first stage of bringing audio into the board. This is where you can adjust how hot that signal is coming in. That signal, if it's too hot, will clip, distort. Too low, and you won't get anything through the system, or to be very quiet, and you'll be fighting it the whole time. Next part down would be auxiliary sends. These can be used as monitors or sent to a monitor amplifier for on stage, whether that be in-ear or the wedge style. You can also run these out to recording systems or streaming systems. It's just another output and another mix that can come out of the board. Then we have the equalizer section. Again, depending upon make that you're using, this could be, it could have a couple of sweeps in the mid-range or a single sweep like this board. This is where you will adjust the different frequencies and try and get the better sound out of each individual channel. Then pan control. This is for left, right in a stereo system, or for picking which subgroup you really want to be at. And then, of course, the output fader. The sound travels from the top down through the bottom. So now you get to the output fader. This is what's going out your main mix. Then on the right of this board, the middle of larger boards, you have the master section. This is where all your final outputs are, any kind of extra mixes where they'd be coming out, subgroups, those types of things. Again, we'll get into a later video about how to use each one of these parts effectively. We're just kind of going over the basic layout right now in just a real simple form. Okay, so the back of the board is going to look kind of like this. You have your different areas for your inputs. You have your microphone input. Again, it's a balanced signal. Then above that, your line input. Again, accepting a higher voltage, hotter signal. Insert. This requires a special cable and a special kind of setup. We'll explain that again later in a different video. And then we have the outputs. You have your main mix output. This could be quarter inch or XLR type of connector. Then your aux sends. Again, these are just auxiliary sends, auxiliary ways to get audio out of the board. And then there's the direct out. This kind of like it says is as soon as that signal comes in, it will feed it directly out in exact duplicate without it altered in any which way, shape, or form. Then we have subgroups out. If you're mixing with subgroups, sending them to different areas, maybe a recording feed, this is where you would connect. Those connections then go into the amplifier. Again, I have a simple Mackie example here. But essentially, on the front, you have your sensitivity or gain input. The one thing to remember about an amplifier is it's always going to expand it to the ratio of however big the amplifier is. So on the front, you're not necessarily turning a volume up, you are cutting down on the possible amount of amperage you could put into it. It's just a different way of trying to think of it. Yes, it will react like a volume up, but what you're doing is if you turn the knob all the way to the right, you're saying don't attenuate any of the signal coming in. Just run it full out. As you turn it down, it attenuates that signal, cutting it back, and therefore not driving the amplifier wide open or hard. It's always a good idea to roll them back a little bit just as a sensitivity or a safety factor. There's multiple modes that you can switch from. Stereo is kind of as it says. Each channel, this being a 2-channel amplifier, is run independently. Whatever goes in input 1 comes out output 1. Parallel is just a way of taking one input and sending it to multiple outputs. It parallels input 1 will then go out to outputs 1 and 2, or if this was a 4-channel amplifier, it'd go through 1, would send out to 4 separate outs. Bridge mode is you start to get a little more advanced. Essentially, it's a single input and a single output, but uses both channels to amplify. So you essentially double, a little more than double, but you double the amplifier's output. And then that goes into the speakers. The simple components of a speaker, you have your tweeter horn, which is all of your higher range frequencies. And then you have your woofer, which is all your lower range. You want to look at trying to set this up for the best coverage that you can. High frequencies are very focused. Think of it more kind of like a flashlight being sent out. It's a beam which has a certain angular dispersion to it. This is what you want to make sure you're hitting all of your audience with. Low frequencies are more like a lamp without a lampshade on them. They will go in every direction, especially the lower they get. They're very hard to focus. They're also, because of the length of them, hard to stop. So that's why you'll get a lot of low-end resonation in a room. There's also subwoofers. These handle the lowest of the bass frequencies. I have some frequencies listed there. 20, usually no more than higher than 200 hertz. We'll get more into that type of sound waves and what you should do for those again in later videos. It's just a small example of what's out there. A crossover is needed to direct the frequencies. These are built into the speakers so that the tweeter horn, which wants to send out sound waves that are an inch to a half inch in width, is not trying to send out something that is 10 feet in length, as in what would be going to a subwoofer. So the crossover tells what frequencies to go to which speaker so that it can reproduce what it needs to reproduce. A subwoofer or even a woofer reproducing a big, long, low frequency sound wave can't even really reproduce something that's very short and very high. But if you run the full signal to each one, it's going to try, and you're going to burn up the speaker. Uh, this is kind of like an important side note, but you should really know on the basics. When you're connecting speakers in a daisy chain, usually monitors across the front of a stage or something to that effect. Each time that you connect a speaker, it cuts the impedance of that speaker in half. Now, again, I said I was going to keep this simple, so just think of it as your speakers are going to be set up at 8 ohms. You cut it in half, that's 4. Cut it in half when you add a third speaker, that's 2 ohms. You really should never connect more than 3. Each time that you do that, the speakers are drawing so much from the amp that you have the opportunity to burn the amplifier up. It will just make your amplifier drive more than what it's capable of doing. When you're setting up and positioning, the coverage is specified by horizontal and vertical. So most speakers are 90 by 60. And basically, if you were looking from the top of the speaker down or from the bottom up, it would be 90 degrees. If you're putting a speaker on a stand, the easiest way to figure this out, stand directly behind it, 45 degrees to the left and 45 to the right, and that's your coverage area. The vertical, it just being 60 degrees in this example, is how high or low it's going. Again, putting a speaker way up above the audience, they're not getting the full volume as they could. You're going to just get a lot of slap back off the back wall. You want to keep it a little bit lower. Again, this is the direction it's going. It's just a common mistake that you. So as we kind of wrap this up, we have your original audio source caught by a microphone or another device that runs it into the audio processor or the mixer, in which case it is blended together, altered in order to make it sound better. And then we run it into an amplifier, which then takes that low voltage, extremely weak signal and makes it into a higher output, large wattage electrical signal, which can then be used by the speaker to turn it back into acoustical waveforms so that we can all hear at a much higher level. So this is going to wrap up this overview, and we're going to talk about mics in more in-depth coverage in the next one.